This is a close-up on the clamps and the container now. What I'm gonna do is I'm gonna lower the clamps until they will clamp the container securely, but don't touch the cap. In the next step I'll go in a manual mode and actuate the clamp and make sure that my container is clamped. The cap is rotating freely and the clamp is not touching the cap. That's very important. It's important to make sure that the clamp rubber insert is not touching the cap. Otherwise there may be some friction in between the rubber insert and the cap, and that's going to make the measurement invalid. I will lower the clamp just a hair deactivate the clamp and activate it again. Now I have a very secure grip, and now the clamps are nowhere near as close to the cap. So this is a good setup for my clamping now. Once the clamp configuration is set, now you can turn the head on, which actuates it, which means the head is lowered, and at that point you can bring the head down. Bring it down as far when adjusting the head pressure. Go in the setup, manual mode, and previously we set up the clamp height already. So that's done. Now lower the head, and I've already set up the air pressure on the back of the machine, so when I turn the head on, which means now the pressure is trying to actuate the head in the up direction. If I put a little bit of pressure from the bottom, I can raise the head manually. So it takes a minimum pressure to float the head or to raise the head. Chuck pressure. The chuck pressure ideally must be minimized in order to get that squeezing effect out of the torque testing. Because what the hand does, even if we don't control it intentionally, we automatically adjust the gripping force as the cap and container start slipping. What you have to do with the machine, you have to set it to a certain chuck pressure in order to minimize that high friction during the squeezing. And right now the best way to test it, if you just actuate the chuck and try to rotate the container. If you can rotate it relatively freely, you know that the friction is minimal between the container and the cap threads. And to make the adjustments, you have to tighten or release the pressure regulators on the back of the machine. Now that my setup is done, I can go in, place the container on the platform, and start the test cycle. And this is I left the cap loose on this container intentionally so I can check out the results, and the results should be very low value. And if I did another test, it should be a low value again, which is 2.7 inch-pounds during this cycle. And now what I'm going to do is I'm going to apply 10 inch-pounds on this cap and then measure the removal torque a couple of times. Before starting the torque application, I make sure that the container, the cap is manually threaded on the container threads, but not tightened too much. And then I place the cap and the container on the platform and start the applied and release test. And now I'll do another test just to show the display during the test. And here is what I'm doing when I'm adjusting the chuck. I'm either releasing the mini regulator or I'm tightening. If I want less squeezing force in the chuck cylinder, I'm releasing the mini regulator. If I want more squeezing force, I'm tightening it. Same thing with the platform. And my settings while I was doing the test on this container is you can see it on this movie right now, and I'll show you something else on the calibration screen. So if you go on the calibration screen and you check out the screen, you'll notice a button on the right side. It says chuck pressure, and here you could actually see what the chuck pressure is and actually the chuck, and then see that number going up. And right now I have it set at approximately at 21 psi, and I believe that was a good setting for me while I was doing the test. So at 20 psi the chuck wasn't applying too much pressure to squeeze that cap on the container thread, so I could decrease the removal torque readout that way.